Let's see how to recall the things that we have done in the last class. In the last class, we have first of all we have to talk about that what is vector. So vector is basically we have to use for the representation of the movement of a certain point with the magnitude and direction. For example, if you are applying a force, for the force, obviously you need a magnitude that you are applying 4 Newton force, and in which direction you are applying a force on the right side, left side, upward, downward, on the north side, or if it is any angle. The length of the magnitude is basically shows the length of the vector is shows the magnitude of the vector, and the arrow sign is shows the direction. Then we have to talk about the different notations or representations of the vectors, that we have to make a single line or arrow or single arrow on the top, so that shows a vector. If you have, for example, vector on this is the direction. If you have to make the same vector but in the opposite direction, so that will become a negative one. For example, if it is A, so on the other side, same magnitude but opposite direction, so it will be negative A. Or we can also show the vector by the bold letter. Then we have to go for the column vectors. I told you the column vectors are written in the form of x, y, where x basically shows the movement of on the x-axis, the horizontal movement, and the y shows the vertical movements. So on the horizontal movement, if you are moving towards the right side, so the value is going to be positive, and if you are moving towards the left side, so the value will be negative. And in the same way, if you are moving towards the upwards, so the value is going to be positive, and if you are moving downwards, so the value will be negative. If you are moving upward, it is positive. Moving downward, this value will be negative. And then we have to write the column vector into the form of I and j. So x component is shown by the I, and y component is shown by j. I and j, obviously, even x, y axes are perpendicular. So in the same way, I and j are the unit vectors. They are perpendicular to each other as well. For example, if you have a vector AB that is 3 and minus 5, it in the column form, if you have to write into the IJ form, it is 3i minus 5j. Then we have to talk about the unit vector. The unit vector is basically a vector that have the magnitude of the vector is going to be 1. A vector having 1 unit magnitude that is used for the direction, that vector is known as a unit vector. So the vectors having a magnitude will be 1. Such type of vectors are known as unit vector. Now, how we can find the unit vector of any vector, that is equal to the unit vector is equal to vector divided by their magnitude. How do you find the unit magnitude? We have talked about here. For example, if you have a vector 7 and 5, I need to find the magnitude. So the formula that we have, that is root x value square plus y value square. Substitute the values, automatically you will get the magnitude. For example, here we are going to find the magnitude, the x value square plus y value square. And for example, if you need to find the unit vector, so for the unit vector, we have vector that is xy divided by magnitude, the magnitude of xy. So the vector we already have, that is minus 12 plus 5, means minus 12i plus 5j, and magnitude that is 13. Separate them. So this is the vector. You can check them. If you are to take the magnitude of this vector is 1. And then I go for different questions for practice. The next thing we have to talk about the position vector. I told you the position vector is a vector that always starts from the origin and ended at that specific point. This is the vector, the position vector of A, because it starts from O, and ended at A. This is the position vector of B because it starts from O and ended at B. This is a very common statement that we have to use a lot of times. For example, if you need to find the vector AB, so we always try to relate them with the position vectors of the points. So if you want to move from A to B, so we'll go from A to O and O to B. Now we have O to B is a position vector, but A to O is not a position vector. So we have to replace them. We are moving from A to O. We have to split them, not split them, sorry, alternate them. We have to make O to A. When you are changing the direction, so it will become negative sign. So ultimately you will get that AB is equal to OB minus OA. We will use this statement a lot of times if you have examiner is going to give you any given vector and you need to be write that vector in terms of the position vector. So we will use this statement. You can make the diagram, but this is must be on your fingertips. Anyone having a question about this thing? Yes, Ali Muhammad,
No, it's
Ahmed
clear.
Hamza, Rahaf Ahmed, Ayad Faullah, Muhammad Nagi.
No, Mr. Clear.
Alright. Then we have to go for some questions and we have to find the position vectors. Look at here in this question, this is the ratio is included. So these are the basic things. Okay, the main concept we are talking about the vectors, so that is same. Now in today's class, we have again talking about the vectors. So first of all, we are just going to be talking about the vectors addition. Means how we are going to be add the two vectors. For example, if you have a vector A, that will be 2, 1. There is another vector B, that is 1, 4. You need to be add them. So you can it by this way. Vector A plus vector B will be equal to 2, 1 plus vector B, that is 1, 4. So it's simply you have to add the x values into the x values and y values into the y values. So 1, 2 plus 1, that will be 3, 1 plus 4, it will be 5. Yes, everyone. Any question till here?
No.
None.
And for example, if you have to write this vector into the ij form, so we have is equal to 2i plus j, 1j or j, and we have b vector is equal to 1i plus 4j. So if you are going to be adding these vectors, vector a plus vector b, so that will be equal to 2i plus j plus I plus 4j. The I value will be added into the I and j will be into the j. So 2 plus 1, it will be 3i plus 4 plus 1, it will be 5j. That is exactly the same thing. Just the difference is we are talking about in terms of I and j. Okay, for example, if we are just going to talk about the visual of this one, so we have vector A that is the vector A is basically 2 on x-axis, 1 on the y-axis. So this is the vector A. This is 1 on the x-axis, 1, 2, 3, 4 on the y-axis. So this is the vector A and this is vector B. And if you want to be sure it, the addition of these two vectors, so let me show you. For example, this is the vector graphically. If you want to be sure it, this is the vector A, and I'm going to be take the vector B. So ultimately, you are going to be get the final vector that start from the tail of the first vector and end at the head of the last vector. This represent A plus B. You can check them. For the red one, it is 1, 2, 3. There are 3i. 1, 2, 3, 4, 5. There are 5 i's. They are same. Yes, everyone. Any question till here?
No, Mr. Clear.
No.
So this is how you are going to be add the vectors. In the same way, you, for example, if you need, he says that you need to be subtract the vector, so you have to subtract it in the same way as well. He says that you have to be A minus vector B. So the value of the vector A, 2i plus j, 2i plus j minus I plus 4j, I plus 4j, so that will be equal to 2i minus I, that will be I, j minus 4j, it is minus 3j. If you want to be show it in the diagram form, so look at here, this is the vector A, this is the vector A, and this is the vector B. But this is the vector B, but we need in the opposite direction because it is negative B. So I just make it negative like this way. So it will be where the first vector will be end, we have to take it on the that side. It is minus B. So my final vector will be this one. This vector shows A minus B. You can see that it is 1 and 1, 2, 3, minus 3. 1 and minus 3. So I'm just going to be shows all the vectors that how you are going to be add into the column vector form, how you can add in the IGFA form, and how you can add the graphic in the graphical format as well. Yes, anyone having a question till here?
No, mister.
For example, if you are adding any few vectors, for example, you have the vector, one vector that is this. There is another vector, you need to be add them. Okay, I'm already adding it. This is another vector, this is another vector, this is another vector. So you need to find the final one. So this is the final one. Let's say this is A, this is B, this is C, this is D, this is E. So this is the basically the addition of A plus B plus C plus D. The red one shows when you have to find the final one, so you have to meet the tail of vector with the head of last vector. Yes, anyone having a question till here about the addition and subtraction of the vectors?
Mister, why did you didn't add E with A, B, C, D?
Oh, sorry, my bad. I thought I had. All right.
Yes, no question.
All right. The next thing we have that is if examiner says that we have parallel vectors, means if you have a two vectors and they are parallel. If two vectors are parallel, then both can be written as multiple of each other. Always remember if examiner says that it is given or you know that if the two vectors are parallel, for example, if I'm just going to draw the vector, this is the vector and there is another vector and they are parallel. Let's say this is the vector A, this is the vector B, and they are parallel. So it means that you can write the one vector as a multiple of the other one. Means it may be 1 times 1.5 times this. It is 1, 2, 3, 4, 1, 2, 3. So in this case, it is 2A is equal to B. You can write it in this way, or you can also write it as B is equal to something of B is equal to vector A. In this case, it is half of B is basically is equal to, means you will take the half of B that is exactly same as A. So means you are just going to be writing the one vector as a multiple of each other, any scalar multiple. This is the scalar multiple, because you have the same direction. So just you have the length, the magnitude is going to be different. So you have to multiply any number to make the same magnitude. This is a very important fact we are going to be used in a lot of things, because if it is for sometimes he says that you have to prove that these vectors are parallel. So what we will do, we are trying to write one vector as a multiple of the other one. If we are able to do it, then this means that the vectors are parallel. If we are not able to write one vector as a multiple of the other one, so this means that these vectors are not parallel. Means, for example, if I'm going to say that we have 2b is equal to a, so a can be written as the multiple of the other one. So means that they are parallel. Yes, everyone, any question?
No, mister.
No.
Okay, there are some more few important points. For example, if you will scalar multiplication, for example, if you are going to be multiply a vector with positive scalar multiple, so what it will be? So it will change the magnitude of the vectors only. For example, if you have a vector, this is the, for example, you have a vector A, you have to multiply this vector by 2, so it will become 2a. So look at here, vector is same, direction is same, just the magnitude will be double. For example, if you have to multiply by 4, so it will be 4 times of a. Okay, if you are multiplying with a positive value, it is going to be only change the change the magnitude. The direction is going to be still same. And if you will multiply a vector with the negative scalar multiple, so it will change the magnitude and as well as direction. The direction will become opposite. For example, if I'm just going to take the same example, for example, if I'm going to be say the same direction, but in this case, it will be negative 4. So it is going to be look like this. The same way it is minus 2. If it is minus 2, so the magnitude is going to be double 2 times, as well as the direction will be the opposite direction as well. Always remember, if you are multiplying with a scale factor, it is positive, so it increases the magnitude, and if it is negative, it increases the magnitude, but it just going to be make the direction will be opposite. Yes, everyone. Any question till here?
No, Mr. Clear.
All right. For example, you have a vector AB that is 3a plus 12b. There are some other vectors, let's say x, that is minus 2a minus 8b. There is a vector 1 over 2a plus 2b. There is a vector 9a plus 36b. Now you have to check that which vector is parallel to AB. You have to be checked that which vector is parallel to AB. If it is parallel, so I told you, you might have to be able to write the vector into the form of multiplication of the other one. So, for example, if I'm going to be talk about the x, it is minus 2a minus 8a. I need to be make a as a 3. You have to be just focus on any one variable. For example, if I want to make a as 3, so what I will do, I'm going to be taking minus 2
zero
as a
point
common.
0.5.
Minus 2, first of all, 2 as a common, it will become a plus 4b, right?
Yes.
Now, I need to be multiply and divide by 3. I have to be multiply and divide by 3 because I need a 3 with a. So it will become minus 2 over 3. Take this 3 inside the bracket. Theta 4 is 12b. Yes, it is ab. Yes, it is. So this means that I am able to write the vector x, the multiple of minus 2 over 3 of ab. It means that a to b and x are parallel. Now, in the same way, we are going to be check the other one. Let's say we have to check the y. We have y is equal to 1 over 2a plus 2b. So first of all, I'm just going to take 1 over 2 as a common to make a as 1. So it will be a and 2b will become, yes, everyone 2b will be v will become, because there is no 2 here.
4.
1.
Or
Yes, 4. When you will multiply them, again look at here, it is 1 over 2a and 2 times 2 is 4, it will be 2b. Now I need 3 here, right? So I'm going to be multiply and divide with 3. So take the numerator 3 inside the bracket. It is 1 over 6. It will become 3a plus 3 times 4
12.
is 12b.
12b.
Alright, this vector is also able to write into the form of this one. This means that the vector a, b and y are parallel. Yes, everyone, you have to be checked about the vector z. Is it parallel?
Yes.
If you have to simply take 3 as a common, it will be 3a plus 12b. All of them are parallel. I thought there will be one is here that is not parallel. Okay, no issue. We are able to write it, so this means that the vector z is parallel to the this one as well. Yes, everyone. Any question till here?
No,
no,
Mr.
Mr.
Rose.
King.
All right. All right, everyone. Let's meet after 5 minutes, and we are just going to be do the practice session. we are just going to be